the system call interface for manipulating files. On the file system, you can get a file descriptor back. This return from open is a file descriptor by using the open system call, where you give it a file system path, and then some flags to say whether you want to open that file in read mode or write mode or read-write mode. You can also add a create flag that creates it, and then there's an extra argument, but we won't worry about that too much. When you're done with the file descriptor, you should close it, and that releases the resources associated with reading and writing that file, the underlying file. So that's the close. The return value here is just an error code in case something goes wrong closing it. Right? As usual, if open returns a negative number, that -1, that means it was an error also. Otherwise, we get a file descriptor back. And you can see the type of the argument to close is also int as a file descriptor. When you have a file descriptor, perhaps from opening a file, then you can read and write to it. And happily, those names are good too. It's read and write are the system calls. Each of those takes a file descriptor. Each of them takes a pointer to some bytes. In the case of read, this is a pointer to a region that read should fill in, and it should fill in with up to n bytes from the file descriptor. Whereas write, you give it a pointer to some bytes, and it will write up to n of them. Now, read and write, for various reasons, may not read as many bytes as you requested or write as many bytes as you provided. In the case of read, maybe there just aren't that many bytes. So the result type here is size t. It's assigned size t, saying that it's the number of bytes that it actually read. It'll be less than or equal to n, or it can be a -1 indicating an error. That's why it's size t, assigned size t instead of a regular unsigned size t. Write is similar. It returns the number of bytes actually written, or it returns -1 to mean an error. So here's a little example. In this example, the file that I'm going to open, you can see capital letter, I'm using the CS app wrapper to handle errors. I'm going to open in read-only mode the first argument, the 0th element of argv, which is the executable itself. So because an executable is a file, I can do that. And I'm going to use read on the resulting file descriptor, read the first 4 bytes. We know our executables are in ELF format, so we know that that's a hex 7f followed by ELF. So I'm going to skip the hex 7f and then print out the ELF. So when we run this program, we should see it print ELF. Let's try that out. Let's call this self.c. It's going to print out itself. Okay. No, I have to link to csapp.c as usual. And when I run it, we do in fact see ELF. And so that's just a basic example of using open and read. You can see I didn't use close. It would have been a good idea for this example, but it gets automatically closed when the process exits.